on like a leaderboard, and so we're on the same leaderboard. So we were frantically last night undoing Duolingo on the couch.
Let's see.
I'm winning.
The sequel to Science.
I don't
the Village.
I don't know.
Not Science.
We're gonna get to this in just a second here.
No, but we didn't do the other Spanish. What do you mean the word?
I don't know, making sure they got their homework straight. No. Let's go with email I sent out yesterday. Did I send an email yesterday? I think I did, yep. Sent an email about the exam. Let's see, due on Friday. We're good as opposed to Wednesday? Cool. All right, are we good with there? And then what I did is I moved 6.3 to be due tomorrow. The reason for it is because I finally on Sunday gave you guys the video for 6.3 homework. All those wonderful numbers of homework. And then so I moved 6.4 to Thursday, thinking you should probably have your homework done before you submit a test. We good?
I have a feeling that I'm gonna watch the video for 6.3 and it's just gonna keep going and we're just never gonna get to the end of it.
Dot.
Yeah.
Did you post an assignment for 6.3 on Google Classroom?
Yeah.
Yeah, I changed them up, and I believe I posted 6.4 for Thursday, and then I posted the exam as well. So the exam, but then I do want you guys to bring in the exam to class, so just a paper copy.
You posted the homework, you posted the assignment for the test on Google Classroom?
Yeah.
I didn't see that.
Yeah.
I saw it.
Yeah, okay.
In fact, I commented.
I looked like every single minute of every single hour all weekend.
That's committed.
I saw it as soon as he. In fact, yeah, I know that I saw it because I actually commented on it.
Grant, stop lying.
Uh-huh.
All of us saw it.
Yeah, except for you.
Adrian saw it. Yeah, even I saw it.
I really doubt that.
Did you have your beanie on yesterday? Maybe that's the problem.
It's keeping the memories inside your head,
I
so
know.
now they're just like, yeah, they're just
Free
I'm
flowing.
having baby withdrawal.
Really bad. Nice.
All right, let's go with it here.
You have a wound that has-
I'm sure I do. Well, the hair.
Why?
Okay, anyway.
Okay, let's go back to this right over here. We have a triangle, if you guys can draw it out. This is just the intro to 7.1. We are going to look at something called the law of sines and the law of cosines, but all about triangles. We go back to triangles and sort of, let's see, things that we have known already, we put together, but it's more of just the consequences of things. So first things first is notice it is not a right triangle anymore. Yes, So we're going to look at non-right triangles. Let's see how trigonometry fits into that. So I got a triangle ABC. How do we usually write triangles in terms of capital letters for the vertices? I think you guys know that from geometry, right? And lowercase letters for the sides. So I'm going to do this here. I'm going to drop a hypotenuse down like this from C all the way to here. And I'm going to label it as H1. And this is where we get creative here. So what I need is I need a sine function that gives me some kind of relationship to H1. Not all at once. This is kind of like the first thing we'll see. And then we got another thing, 7.2 and then 7.3. So each one of these sections will sort of have a consequence of something. Like, oh, wow, that is so cool how that fits together. So non-right triangles, here we come. And go for it. You guys just jump at it, if you, whatever you think.
Yeah, I was gonna say sine.
Except for Matthias, because he doesn't have his beanie. Sine of?
Yeah, I would vote B because we know the two sides, whereas the sine A, it's like C divided into a portion.
Yeah, can't connect C at all, huh? Okay, so how about sine of A? So that works. Sine of A equals? I go with that, H1 over B. Good. Any other one, because this is the connection. Like, oh, wow, after you see that, that's so super cool.
Adrian said sine B. too.
Oh, yeah, okay, sorry. Adrian, you said sine B equal to? Anybody with the ratio? H1 over A, and that is cool. There it is. We're getting off the right triangle. We have some relationships happening here. How about this? For this one right here, let's multiply both sides by B. And I got myself B sine A is equal to H1. Jump to the other side, can do the same. A sine B is equal to H1. That's cool. It doesn't look like art, but to me, that's art. That makes sense. It's like, you're just sort of seeing something awesome and creating something out of it here. Maybe instead of partitioning words and verbs and pronouns, it's actually partitioning variables and seeing how they fit together. Okay, I think we're good. Are we good? Notice what we have here. We got two things equal to each other. How about this? B sine A is equal to A sine B. Love it. There's a relationship that we did not know before. Let's do this here. How about let's divide, just to make it look nice. This is the way it's always written. Let's divide both sides by AB. Answer the question, Mr. Edgar, why you do that is because it just looks a little nicer. How about this? That is a lot of signs. So we have this, we don't need the right triangle anymore. We have a relationship that gives us a relationship between this angle A and its opposite side, angle B and its opposite side. Are we good? Sweet. This is
It
so
would be fun
awesome.
just to just stay with the right triangle.
I agree.
Oh,
I like right.
Look,
no, it just crushed me for chapter 7.
You just stop. You just told her to trade the right triangle.
I don't want you to have to teach a whole new thing.
I think
Thank
it's
you
easier
so
for
much.
all of us, really.
Sure.
Yeah, we just move on.
I'm thinking about it in terms of you.
Yeah,
Right, yeah,
exactly.
thank you for my comfort, yeah. Let's do this, same triangle, right? So we still have the same triangle. How about this? Let's just cut another side. We're gonna go from A, angle A down over here. It's supposed to be a right triangle here. We're gonna call it H2. So notice we haven't changed our triangle. Triangle's still exactly the same. Give me two more relationships.
Sine of C,
Okay, yeah.
which would be H2 over B, right?
I go with that. Everybody okay with this? This way, it's this one right here. So it's the opposite side and the hypotenuse in this case. Okay, awesome. One more.
Sine of B
Mm-hmm.
equals H2 over C.
Over, yeah. C or little c. Okay, well, let's do the same. Let's go for it. Let's multiply B on both sides here. It gets me B sine of C is equal to H2. On this one, multiplying here, how about C sine of B is equal to H2. And let's do the exact same thing here. Set each of them equal to each other. So that guy is equal to this guy. Awesome. What do we do to make it just look nicer?
Divide.
Divide by BC. Awesome. B's cancel. That is so cool. Wait a minute.
Whoa.
Yeah.
So they're all just equal to each other?
Yeah, actually, yeah. Now we have sine of b is equal to sine of b. So how about a triple-sided equality? So that one is equal to this one, which is also equal to this one. That's so cool. And it looks so nice because the letters correspond to each other. Okay, now do we use all three of them at once? No, we don't. We just understand there's a relationship between all three. But we normally just use two at a time, whichever two we need.
And
Okay,
is
go.
that the law of sine?
So this is the law of sines right here.
Okay.
The only other way it's written, it just says there's a relationship between all three sides and all three angles, and that's the relationship. The other way it's written is like this. Just flip it around. So I have this equal to this. So there's your two law of sines. Doesn't matter which one. Books are getting lazy these days. Because when I was growing up, besides walking to school both ways in the snow uphill, we only were given one. Say again?
Like 80 miles, probably.
Yeah. Oh, that was the good day.
Your school changed locations, you had to walk farther some days.
We had to cross the Rockies actually.
We have motor engines. We had to hike up in the
Yeah.
snow for hours.
Well, you guys, Monday, Wednesday, he had 0 periods.
You didn't get to sleep, you just had to leave at like 10 p.m. the day before.
Exactly.
We were only given this one on top, so then there's a little bit of benefit of having both, just understanding that you can plug it in, because then when you solve for something, you just leave it on top, which is a little easier.
Wait, so the book's getting lazy or are we getting lazy?
Books are getting lazy.
Well, the books are giving us more information, so the books are actually working harder so that we can be lazier.
There you
Yeah,
go.
exactly.
I got a calculator. Okay, there it is, law of sines, we got it. Okay, so now, if we should go back, we should say chapter 7, gonna label it, if you haven't labeled it already. Try triangles, what we're into now, and we should say non-right triangles, that's kind of what we're doing here. And 7.1, the law of sines, which we just did. Awesome, okay, how does it help us? Let's get to some problems here. Thought that was pretty cool. Okay, so there's a law of sines. If you want to just label this as the law of sines, that's cool. But real quick, there's an easy consequence here. So let's jam to this one. We do have to talk about something here. No, let's go to examples here first, then we'll come to this here.
Oh, wait.
Ooh.
Really? Remember when they were saying like, which ones do you have to know to correctly solve the triangle?
Oh, ouch,
I don't
sorry.
remember why.
Almost
I
made
don't remember what I said for that either.
it. So we'll go with the exercise 1. We have capital A is 5 degrees. Whoa, that's small. Let's see, capital C is 125 degrees. So see if you can kind of draw it to scale. That's kind of what we're looking for. B is 510 yards. That we're just solving for A. So triangle ABC, it doesn't matter if you go counterclockwise or clockwise when you label stuff, but as long as you know which one you're doing. Let's see, for angle C to be huge, I think it has to go like this. Something like that. And it's very, very flat, I guess, like that, right? Will that work? So that's A, that'd be B, that'd be C. Is it kind of the scale? It's kind of the scale.
Wait, can I draw like A?
Sure, that's fine too. Now, do you have to draw it to scale? You don't. It just makes it look a little easier to sort of think about what you have here.
Quick, let me whip out my yardstick.
And 510 of those.
Yeah.
Yeah. Because you're not allowed to like move the yardstick, you have to place each
Uh-huh,
individual.
sure, absolutely, yeah.
How big is a football team?
I got 5 degrees here. I have 125 degrees here.
Yards.
So our job is just to find A right over here.
It's pretty big.
So notice on the law of sines, you always have to know the sine value of an angle and its opposite side. And that's how they work. And that's the SAT question there.
Yeah.
Well, you always have to know what.
You have to know its angle and its opposite side, or at least one pair.
Oh, I don't think I've done either, but that was definitely one of the answers.
Yeah.
Well,
So I have one pair that I want. Here it is, angle A, and its opposite side is little a. That's cool. So let me write this off to the side. I have sine of A over little a. That's what I'm going to use. Now what's the other one that I should use?
C. Like side of C. Oh, wait, never mind, yeah.
How come? Talk to me.
Because you know you know what side B equals.
Yeah, you know side B. Can you get angle B somehow?
Oh.
Yes,
How come?
add 125 and 5 and then subtract it from 180.
Perfecto. We still have this little
We can
rule.
still do that.
Yeah.
I thought if it was a right triangle, we might not be able to do it.
Only right triangle.
That little rule still in play, right?
Are we calling it stupid, Graham?
No, they're having their own little interesting discussion.
This does not concern.
Yeah.
Yeah.
We should do that from the
Didn't
first
even
day of
hear.
school. Yeah. So let's go with it here. So let's say 180 degrees minus 125 minus another 5 degrees. Give me that. What is that? 50? Adrian says 50. I agree. So now I have, let me erase this a little bit.
Using the angle.
Okay, now I have it here, 50 degrees this way. And there's my opposite side. That's cool. So I'm going to use sine of A over A is equal to sine of B over B. That's the relationship I want. Let's plug in stuff I know. And yes, you need your calculators with you for these guys.
Maybe I
You would
do
send
have
money to the
an
Nigerian.
angle.
I was gonna ask.
Uh-huh.
He would, about the very bad. He would. Yeah. You know you would.
All right, for this one,
Too good for,
I'm too good
to
of a
send
person.
money to my grandparents.
I convinced him he had to stay home for 2 weeks after getting a second shot. Forgot about that.
Convince is a strong verb.
You needed to be told.
all right, on this one, notice the A's on the bottom. So if we're going to use this relationship right here, we're going to have to get A by itself and not in the denominator. So what normally we do is we just cross multiply first.
Can we
Just to get
start with the other one where the little a's already on top?
Hey, that is so cool. I think we'll get there.
I
A.
wanted to cross multiply.
Side 50.
Try to avoid all costs.
So by cross multiplying, we get rid of all our fractions here. And then now we have to do one more little thing, which is divide by sine 50. And eventually, after a while, you just know how to do this mentally. Or you start with the other equation, which we'll do in just a second.
I mean, I think we were already doing it mentally, right? Like, we were using our minds to do it. We weren't like counting out apples for sine of 5 degrees.
Meaning without writing things down. All right, on a calculator, what is 510 times sine of 5 degrees divided by sine of 50 degrees? And make sure you're in degree mode.
Yep.
Say again.
58.
Just 58? Everybody second that? Yeah, 58. Okay,
58.02460836.
gotcha. We'll go with 58 then. 58 yards. Done. All right, just to make it a little bit faster. Whenever you're solving for a side, what we do is we just use this little formula right here. So let's do it again, just real quick here, just to sort of see. And that's why you were given two different formulas. If you're solving for a side, it's easier to use the flip relationship. And as you plug it in, A, we don't know. This becomes sine of, is it sine of 5 degrees, is that right? 510 is on top. And sine of 50 degrees. Are we good there? Sweet. Okay, if that's the case, you don't need to cross multiply if you're Georgia. What we do is we just multiply what we know, or actually the denominator of what we don't know, and we get the same thing. A little bit faster with a little bit of sort of thinking through on the front end of things. Okay, are we good? Like that, that's cool. Done. This is cool. I like it. All right, Jam, next one, all yours. Now B is bigger, C is small. So again, kind of thinking how would graph this out. B is more than 90 degrees. So I'm thinking maybe something like this. See if you guys agree with mine. Is that about right? So part of it is kind of sort of drawing your triangle so that you know what it looks like. Got that right there. All right, this guy is 110. How about 40 over here? A little b is 18. Trying to find C. All right, you guys talk to me here. Which one did you guys use? Which formula? Sign on top or sign on the bottom? I'm gonna go with the Maya here. Sign on the bottom. So it's sine. Something like that, is that right? C over sine C? And how about B over sine B? I think it's pretty cool, pretty nifty relationship, the fact that we do that now. So sine of 40 degrees is equal to 18. Sine of 110 degrees. And then some people, by the time you guys have enough practice with this stuff, you probably can put it into this little piece right here, because it's really just moving one sine value over to this side. And answers, anybody?
12.3 inches.
That's cool. Waiting for this to catch up. Are we good? Okay. Boom and. Oh, yeah, just the 3 different relationships there.
A equals 80.
Yeah, 8 equals 80
80 degrees.
Oh, 8 degrees.
80.
80.
Oh.
How
I
about
like
that?
You were right the first time.
Bless you. All right, all yours from beginning to end. That's another change. Okay. Let's see, 80 degrees. So that's almost 90 degrees. B is 30. So let's see if this makes sense. Something like this. Is that okay? Got there? Let's see, because 90 degrees would be about right here. So for angle A, it's a little shy of 90 degrees. B looks small, so C would have to be the bigger angle here. So 80 degrees, 30 degrees, find little a based upon the fact I know this one right here. All right, let's see if we can get to this place here. Instead of writing down the formula, can I just go to this? Wait, a over sine of 80, how about 14 over sine 30? And punching into the calculator something that looks like this. Not just something that looks like that, it better be the same thing. And what'd you guys get?
27.6.
Centimeters. Okay, awesome. Okay. So again, just quick 3 examples to give you a relationship between all 3 pieces here. Well, we can do this one. Let's do this one. So example 4, move to example 5. We don't have traffic lights that hang here in California, huh? Anybody seen a hanging traffic light in California or no?
No, like she was,
What the hell?
So do we have to write like
Were you gonna
the
say we're
problem
all
or
hanging?
something?
Yeah, just do the diagrams,
You
fine.
know, what do you think about it? We're all hanging traffic lights.
No, we're all just hanging.
Yeah.
From what?
Quantum strings.
No.
That what string theory is? We're all just puppets?
Yeah, that's what strings are. You're right. Papa.
Then you
So where do
go.
we put the 22?
Keep going.
Let's see, traffic light hanging 22. It's,
Don't use your mouth.
so if you guys want to write the diagram or draw the diagram, let's label it as we go here. We're trying to find tension 1, tension 2. And the 22 is going to go right over here, right next to the traffic light, because that's how many pounds it is now. One little thing with equilibrium in physics, because the traffic light is standing still, it's not falling down. We should be able to make a triangle out of this. So we have these little vectors. We have vectors here, okay, here, and this one. So somehow it should form a triangle for us. So if we can kind of move it off to the side, let's take this down vector right here. There's my W vector or weight. I could put a little 22 next to it. And then what I'm going to do is I'm going to take this whole piece right here, this little T1. That one, I'm going to bring it up on top and bring it right over here. So it should form this little guy right here. And then this little tension 1 value, bring it over here, and it should form that one there. Are we good? So let's label these as we go. This is tension 1 brought over. This is tension 2. It should fit into a triangle because the traffic light is standing still. It's static. If it's not static, there's movement in it, we can't form the triangle. Okay, now the fun part is our angles.
How do the lengths of the supports equal the tension?
Yeah, I was,
Why did they hang it with?
Like, because it looks like that's what they're labeled as, right?
Uh-huh. How do they equal tension?
Like, yeah, they're just, like,
Oh,
how
yeah,
are they
sure,
the
sure.
same thing?
Uh-huh, sure. Because these guys are not, in physics, we don't think of them as lengths. We think of them as pressure or tension. So all these, instead of having just edges, they have arrows next to them. And so all tensions, when something's stagnant, have to technically equal 0. And that's why you can form the triangle. Start throwing you into a different world here.
Yeah, I guess, so if the length was different, would the tension be different?
Yeah, so if this was,
Yes.
whenever we think of rays,
Yeah.
this ray is 10, this ray would be 20. And so the magnitude of the length of that ray determines the tension on it, or pressure. We can do pressure. We can do rate as well.
Weighs the same no matter what length the string is.
Say again, say
The
again.
traffic light weighs the same no matter what length the string is, right? So how can it be pulling harder if the string is a different length?
So let's see if this makes sense here. If the traffic light was like this, hanging down very, very low, there actually would be a different tension on these two pieces. So the length of the, and if the wire was like this, very, very shallow, and the traffic light was right here, that causes a different tension on there. It's much, let's see, I wonder if it's still giving the same tension added up. It'd be different tensions of which one.
So that seems like it has more to do with the angles than the length of the string though.
Sure, yeah.
So then why is the length the one equal to the tension?
Because let's see, not so much. It's the fact that we label it as this right here. This is 22 pounds, right? But it's the length in terms of magnitude. It's not the length of the rope itself. Even though the length of the rope itself has to do with it because the angle changes.
Okay.
So it's more about the angle change than, I mean, the length of the rope and the angle change has a correlation between them,
Yeah,
but that's the connection between them.
okay.
We're good? Or no, not,
Well, I
not.
mean, I just don't like it very
Yeah,
much, but
okay.
yeah, sure.
Okay, we need, let's see, we need to know some angles here. Some angles that we know.
Okay, the one between T2 and T1, is that 105 degrees on the little diagram we drew? Or am I making?
Yeah,
that
let me
up?
label these here. So this is
Okay.
angle A here. All right, let me just put angle A here. That'll be a little easier to sort of think things through here. No, I better not because we connected different pieces together here. So I'm gonna. Can I go DEF? Let's go to this. DEF would be a better choice.
Yeah, so would angle E be 105 degrees? Or is that something?
I'm gonna put a question mark there, 105. Let's see, when we do this piece right here, it's still going down no matter what, right? It's going straight down. So we can kind of think of this little thing sliding up over here. And is that the same thing as this little piece right here? I remember because we brought T1 down over here. Good there, so we're gonna play with angles just for a second here. So this is 60, good there. In fact, let's talk about this one now. The T2, how do we get angle T2? This one, notice it's going up this way, right? It's going up this way. So if I were to slide this little piece over here, it's still going straight down, right?
Are there?
Yeah, it's like that rule about the two parallel lines and then if you have a left.
Cool, yeah, transversal, absolutely. So if this is 45 degrees, this guy better be 45 degrees. And so that means this guy right over here is 45 degrees.
So why? Wait, are there arrows on, because I know there's an arrow in the original diagram with the little picture of the traffic light. There's an arrow going from the bottom. Is there arrows on the other lines?
Which other
That's what
lines?
I can't
Yeah,
see.
sure. Go ahead. Let me erase everything. Go ahead.
So yeah, there are arrows. I'm sorry, it's just blurry. I can't. There are arrows. So is the reason that you can't just like take that angle and then just like, because in my mind when I was doing it, I just took that angle and then flipped it like this and then put the thing there,
No, because then you're reversing
the direction of the
directions,
arrows.
yeah.
Okay, that's fine.
If anything, what we think about is doing this here in physics. We think of either moving this up, this little value right here, we move it up to here, or the other direction is we just extend this line down here. Then this line gets moved over here. So
Okay,
it's either moving, one line gets to go down, we just extend it, and this line has to move over here.
okay. And so
That's the other
is
way to do
it,
it.
sorry,
Good.
is it just the direction of the arrows? That's like a different equation that decides which way the arrow directions go, or there's like a certain factor that determines that?
If we, let's see, we have to keep the lines going the same direction. We get to move them around separately in each piece. So it's almost like we have this guy right here. We have the pressure down, we have this piece, we can just move around anywhere we like. And then this one right here. So we have these three vectors.
And so you know that one, no matter what like kind of problem or what tension is being put on a figure, it has to have one of each of those arrows going in some direction.
So if we place them like this, if we put this down arrow like this right here, we move it down to here. We move the up arrow this way. Notice this guy can't get back to form a triangle. Now we're stuck. There's no forming of triangle. So then the question is, how do we put this together so we still form a triangle? If this guy comes down this way, and now we can bring this one here, and now we formed our little triangle.
Okay, so does that happen sometimes where you have ones that just won't form a triangle and you just can't do anything about it?
Only if the traffic light or the object is still moving in a certain direction. If it's stable, they have to form a triangle. In a sense, what they're doing is canceling out all the forces. That's cool. All right, we've got some physics lessons today. All right. Any other questions? That's cool. Okay, so if that's 60, that's 45. You guys talk to me here. What is angle E?
Not
Yeah, that's cool. It's actually the supplementary angle of those two right there. And that's the other way to do it. Eventually, when you do this here, you don't even think about the rotations. You just know which angles are going to form. Okay, talk to me here. I need T1.
Wait, so T1 is AC.
We relabeled it over here, right? So T1 is this little piece right here.
Yeah. Like when it says find the magnitude.
AC, yes,
Okay. Wait, so are you asking? You want us to solve for it?
Somehow, but talk to me. Whoever got it, talk to me. How do we solve for this T1? And I guess we should label it here. So T1, because it's magnitude, we should go like this. It's going to be in these little bar lines. It's just to give you the correct notation. Because we're not thinking about it as a length of a line, we're thinking about it as tension on a line. Okay, so how about this? Tell me if you guys agree. T1 over sine of 45 degrees is equal to, that would be 22 over sine of 75 degrees. Agreed there. Cool. I'm running out of space. Let's see if I have more space here. This was, let's see, 22 sine of, what is it again? 45 over sine of 75, and answer is 16. We good there? And next one would be tension of 2 sine of, I assume it's 60 degrees, because the 22 and the 75 are not going to change because they're the other side. 2 sine of 60 over sine of 75, and that one.
Oh, 19.7.
Okay. Awesome. Let's see. I guess one of the students in the calculus class, I'll let you guys guess who it is. Bless you. When they go mountain climbing, they were talking about the same thing happens with mountain climbing. So when you do your safety cords when you built it in. Sometimes they already have pre-made chains here. And sometimes you actually drill into the rock itself here, but right, when you have these two pieces right here, you're going to connect a suspension rope. You do the exact same thing here. So if you connect it like this, you're going to fall because there's too much tension on this little rod right here. And so what you have to do is somehow make it so that when you have the lengths of the rope, super, super important. When you're going to connect it this way, you get to live because the tension is now not as much on this little piece right here. And so length does connected tension because of the angle values. There it is. And so you want to be mindful of that. I think we have just enough time here to do one more, I think.
So what are the 16 and the 19.7 measured in? Like, what are their units? Is it pounds?
It's pounds,
Okay.
Should put that here. Pounds. Oh yeah, that's right. I did do a little, see, I forget. This little guy here, where are we at? I did move him around, huh? Like that. Right, you got this little tension here, put in, got this little piece that is going to be moved over, and then you got this little piece that's going to move over this way.
Whoa.
And so somehow has to form in a triangle some way. I think we are done. As far as it's concerned. Have a good day. Enjoy the day.
Oh, God, remember that.
Oh my gosh, I
History
forgot about
test.
that in.
And then that,